All right. So, guys, let's start working on this matter, yeah? So, it's functions again, linear functions for now. This is the beginning of inverse functions. So, for inverse function, I always say, you can either do it two ways. The first one, you have your function over there, which is y equals to ax of plus q. When you find the inverse, or the process of finding the inverse of this linear function, in fact, this process applies to all other functions as well. So you have what? You have you have your function, which is y equals to something something x, and then you try to write it in a form of x equals to blah 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 blah. So you write x subject of the formula. Né? That's the first thing you do, or the one way of doing it. Once you have done it, you have x equals to blah 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 blah. Once all that is so, and you have your x like that, but I'm telling you, the next thing is you're done. Secondly, you can you have your function. The first step, you can swap x and y, and then you write y as the subject of the formula, right? So I'll show you with both things. So the first one, I'm like, okay, I'm writing x as the subject of the formula, so I have y ax equals to y minus q. Then I'm going to x equals to y minus q divided by a, right? And then I am done. So then what I would do is I would say f of x. But for functions, so remember this, I can write it as f of x equals to ax plus q, right? So now when I'm done writing, when I have my x as a subject of the formula, the next step I would say f -1. This is how inverse function, or how you can see that this is an inverse function without the people saying, okay, here's an inverse function. So all right, cool, that is the case. So equals to, now where I see x, no, where I see y, I'm gonna write x. So I have x minus q divided by a, right? Then this is my inverse function, right? This is my inverse function. Yeah, that is my inverse function. Cool. So what's next? Next is the other step. Yeah, the other step is like, the first thing you do is, you see here we try to write x as the subject of the formula, right? But here the first step you do is you swap x and y, so you have x equals to y a plus q, and then you write y as a subject of the formula as per usual. Okay, so you'll have ya equals to q, oh yes, x, because we transpose q, x minus q, then you divide by a both sides, right? Yeah, then you have y equals to x minus q over a, right? And then you see that they match. So now what you just do is you do your thing, -1 x equals to x minus q divided by a. This is the equal sign. Yeah, just like that, friends. That's how you do it. We have this example down here, so we're gonna practice with it. To get it right. Yeah, so we need to plot and plot both, or craft both, sketch both of these function, is the original and the inverse. I'm gonna start plotting the original first. So plotting the original, for linear functions, I think this works with for all functions, bro. You just look for your intercepts. I think it works for all yeah, I think all of them. Yeah. So here you have, what do you have? here, right? Here, x int y equals to 0. So you have 0 equals to minus 3x plus 1, 3x equals to 1, x equals to 1 over 3. This is 1 over 3, right? Cool. So x is 1 over 3. Y int x equals to 0. So now y-intercept x equals to 0, so you have y equals to 0 plus 1, which is 1, right? So you have y equals to 1. Y equals to 1 here is, maybe let me put it here. Say this is 0 0.5, this is 1, right? So our graph, when we do now plot it, it'd be something like this. Cool. Yeah, it'd be something like that, right? So we're done with what? There's a theory that I have. All right, the theory is, so of course, you know, this is your y-axis, this is your x-axis. So you see, like, we swapped, when we find in the inverses, we swap y and x. My theory is that when you plot the inverse function is exactly this, but now you do this. Yeah, I don't know if it actually showed, but like when you turn your graph like this, and then in such a way that you turn it, then you'd say this is your y-axis and this is your x-axis, because you technically swap them. So I'm guessing that the y is gonna be something like this, you know, but like now with, like, not like when you plot your inverse function, I'm guessing it's gonna be something like this. I don't know, that is just a theory I have. We have a chance to probably test it. So inverse function, right? So for this one, let's start by swapping. So you have y equals to, then we swap them, right? Now we write y subject of the formula, we have 3y. Then what we have, divide by, so we have 1 over 3 minus x over 3. Right, therefore your inverse function is minus 1 over 3 minus x over 3, right? So from that inverse function, we can then calculate our intercepts. So for x-intercept, y is 0, so therefore we have 0 equals to 1 over 3 minus x over 3. We transpose, so we're gonna have x over 3, we multiply by 3, we get x equals to 1. So we have x equals to 1, right? Cool. And then that was x-intercept, so y int x equals to 0, so y equals to 1 over 3 plus 0, 1 over 3, so y equals to 1 over 3, right? So this becomes very interesting. Look at the value of x, look at the value of y for both the original and the inverse. The value is also swapped, and I'm sure you can guess why the value swapped is because we swapped y and x values. Yes, because we swapped the value of x and y, right? When you find the inverse function, remember you swap them and then you do your workings, or you do your workings then you swap them, right? So that's why the values change. So plotting this, it will be x is 1 over 3, 1 over 3 is here, and then 1, yeah. Oh, x is 1 actually, oh no. So x being 1 is gonna be here, and 1 over 3 is gonna be here, then you'd have something like this. Better. Yeah. Oh no, not better. Hey bro, it's fine, bro. It's fine. I'm sure you guys get the point I'm trying to raise. This guy is just having some yeah, no, this thing is having some nasty attitude on me. But yeah, this is basically it. This will be the f minus the inverse, and then this will be the original f of x. But yeah, basically the y value and the x value stay swap. Now let's see further. Here x x-intercept y equals to 0, so you have 3 to x, you divide by 2, and then x is 3 over 2, right? So x is 3 over 2, or 1.5. Y-intercept, you have y, 2 into 0, minus 3 equals to 0. I want to assign equals to 3, right? No, so y equals to minus 3, right? So from there I can ask a question and be like, so guys, what are your expectation in terms of the value of x and y for the inverse function? So I would say x is gonna be minus 3 and y is gonna be 3 over 2, or 1.5, right? So let's work it out. You have y equals to 2x minus 3. X is the subject of the formula. You have 2x equals to y plus 3, divide by x, so we get y plus 3 all over 2, right? So with this being said, you can say therefore f of x, the inverse, y x plus 3 divided by 2, right? Now after all this is done, you find your intercepts to properly plot this one. So you like x into y is 0, so you're gonna have 0 equals to x plus 3 over 2. You multiply by 2 all over, this will go, and then you have that. So therefore x will be minus 3 because it transposed 3. So we have x minus 3. Our, we were right by suspecting x to be minus 3. Let's check for y int x is 0. So now we have what do we have? What do we have? We have y equals to 0 plus 3 all over 2, which is 3 over 2, which is 3 over 2, which is 1.5, right? So we were right. So you're seeing that here the values of x and y, they swap. They swap. If on the original, so basically what I'm saying, it's just a yarn trick. If they give you a linear function and you plot it, right, and then they ask you like, can you plot the function of the inverse function of that linear function? If you know the intercept of the original, bro, you will spend seconds, bro, because you just, if you have x being 1, you know that y is gonna be 1. X being minus 2, you know y will be minus 2. You see, so yeah, sure, that's it. And that's it for this video. So yeah, linear functions, this is how it's done. Also, something I didn't talk about, I don't think it's really important for this one, because it's easy to know or see even. the domain and range, they will always be from negative infinity to positive infinity from here. Or you can say for domain, x is an element of real numbers. For range, x is an element of real numbers. No restrictions at all. So yeah, let's move on.